All right, good afternoon. This is Ms. Cater's 8th grade science class, and we are studying magnetism from electricity today. You need to know the definition of electromagnetism. Electromagnetism utilizes electricity to create and use a magnetic field. This relationship between electricity and magnetism was first discovered by a scientist named Oersted. Electricity and magnetism are different parts of one force called the electromagnetic force. Okay, so you can produce electricity from a magnetic field, or you can produce a magnetic field from electricity. They work together as two parts of one force. Moving an electric charge, which is what electricity is. Remember, electricity is the flow of electrons. So moving electric charge creates a magnetic field. When a wire carrying a current is looped around, the magnetic fields combine to make the wire act like a magnet. So when you have a wire looped around like this one, the magnetic fields combine because there's a magnetic field that will exist around the wire. And so when you loop it around like that, all of those magnetic fields begin to combine and the wire acts like a magnet. The magnetic field that's going up through the center of that coil of wires is very, very strong. So the magnets that are produced by running a current through here, which we call electromagnets, are very, very strong magnets. The more loops you have, the stronger the magnet is. So if we tightened up our coils and had more coils, that would make a stronger magnet than when they're spread out. The definition of a solenoid is a coil of current-carrying wire that causes a magnetic field. That's a solenoid. And you've probably heard of a solenoid switch. Those are used in various places in your cars and in different places like that where you need to have electromagnet, where you need both the electricity and the magnetism. If you place a iron-based magnet, ferro means iron. Remember, that's where we get the symbol Fe for iron on the periodic table. So if we place a ferromagnet, which is an iron-based magnet, in the middle of that coil of wires, so here's our coil of wires, and if we place our magnet in the middle, this is what we call an electromagnet, and it increases the strength of the magnetic field produced by the solenoid. So when you turn the current on in the solenoid, those electrons begin moving. As they're moving, they create an electric field. But then when we put that magnet in between there, that just magnifies that magnetic field even more, making an electromagnet very, very, very strong. Changing the current in the wire can change the strength and direction of the magnetic field. So if we change the current, we can change the strength and the direction, because when we are changing the current, we're allowing more or fewer electrons to pass through, and that will determine what the strength of the electromagnet is. The current can also be used to turn the magnetic field on or off. So if sometimes we want to have a magnetic field around, sometimes we don't. So a current can be used to turn that on and off. You can manipulate the current and the magnets when making the devices that we use every day. Oops. Electromagnets can take electrical energy and change it into motion that can do work. So we can take electrical energy, turn it into motion that can do work. Remember, energy is never lost. It only changes from one form to another. So we can take electrical energy, we can turn it into mechanical energy, which can then be used to do work. Electromagnetic devices change electrical energy into mechanical energy, and here are some examples. When you ring a doorbell, when you use an electric motor like we did Tuesday and Thursday, loudspeakers and galvanometers. A galvanometer is used to measure a small amount of current, and some places that you might see those are gas gauges. Sensor that it's used in gas gauges where the sensor is in the gas tank, reduces the current as the tank gets low. So that's how the little E light comes on or the bell will ring. There's a sensor inside the gas tank, and when that gas tank gets low, it reduces the current going through that switch or that galvanometer. Electric motors. We use an electromagnet to turn an axle. When the current flows, one side of the armature is pushed, the other side is pulled. So it's going to cause this thing to spin because one side is pulled while one side gets pushed. So it causes that axle to turn. When current flows, one side of the armature is pushed, the other is pulled. Current continues to change direction, which causes the axle to spin. Here are some examples of electromagnets. We have mass transportation trains. We have these garbage pickups, or large cranes that will pick up items and only the metal stays with the magnet. The other substances are dropped away.